Alright, so welcome everyone in the second lesson. Now we are actually gonna start programming, but first we will go through some pretty important things. You can see what we'll cover right here. It's actually a lot, so this is maybe longer than an hour, but I think we'll see. I think we'll see how it goes. And then it's also beneficial if you just practice on your own because these are the fundamentals of coding, especially related to Godot. So yeah, practice, practice, practice. That's all I can recommend really. Okay. All right. There's a lot to cover. So the title is Parts and Syntax of Code. We had a project, the other lesson that I opened, this one. It doesn't have anything in particular, but I'll keep it open. This is what we'll work in. Oh yeah, don't worry about this. Okay, so I don't know where to start. This is like so huge of a thing to cover. Okay, so in programming, basically the point is to make things work and solve issues, create software to produce accurate results. And so I would say there are three building blocks of coding, which are classes, variables, or simply var. You can use var as a shorthand to name them, and functions. So just what are these really? Okay, so variable basically means data. If I say 2, that's data. If I say hello, that's also data. If I want to define a color like black, that's data as well. However, it's actually built using a more primitive data type, but we'll get into that in a bit. Okay, so variables are data. That's what they are really. Like, there's no easier or other way to put it. I don't want to make it convoluted. And functions, as you could tell, they use them to create functionality. And how do we do that? Well, essentially by manipulating data, right? Because if you think about it, if you want to make your character move to the right, what do? You set its position, if you have your guy and you want him to move to the right, you need to set the position data. Position is also a variable, and in the 2D space, we have x and y coordinates, right? For the horizontal and vertical axes. And well, this is kind of trivial, not trivial, but not very important to cover all this stuff we have right here. But if you want to move to the right, you would adjust the x coordinates, So yeah, functions manipulate data essentially. It's just a heap of data manipulations, because you can also just batch a lot of things together. So if you, let's say, wanted to fire a weapon, right? You would have to play the shooting animation and also like decrease the ammo count, right? And you can do that in a function. We will we will see this more practically in a few minutes, but I want to go through these three things first of all, and then we will also go into data types and all those things. And what is a class? A class is, if you want to put it simple, it's a collection of variables and functions. Classes are basically ways to identify object behavior. Like you could have a weapon class. If we want to use the previous example of just doing a shoot animation and that whole execution of things, but you could have a player controller or a character as a class. One interesting thing is inheritance between classes, because you could have a weapon, but a pistol is gonna behave differently from a shotgun, right? And then if you wanted to have something more specific, like a silence pistol, that could also be a child class. And this could go on and on forever, because yeah, classes can inherit as much as you want to. Like, how do I put it? The inheritance can happen throughout multiple layers. However, one class can only inherit from one single other class, and we call the class that extends from parent. And these are the children, the pistol and shotgun. However, the silence pistol is also the child of the weapon, but not directly, right? The silence pistol's direct parent is the pistol, and well, you could say its grandparent is the weapon, but we don't really use that terminology. So yeah, there's that for inheritance. And you will see that if we check out the Godot documentation for like node, which we talked about in the previous lesson, you can see it writes inherits object, which means node is a child of the object class. And object is basically the top of everything, base class for all other classes in the engine. And then you just see this huge list of which things inherit from object, basically everything. But yeah, there's that for inheritance. You may remember from the previous lesson also that we talked about functions like ready, right? Because ready is a function as well. It's actually inherited in every single instance because a node has it. You can see they are either called functions or methods. Method is a term used under certain circumstances, or like not certain circumstances, but people. Well, I'm trying to like describe it very in a very different way because you don't know the thing I would need to mention for this. But so methods as a name were introduced with object-oriented programming, if I'm correct, but that doesn't really matter for us. We will talk about object-oriented programming or OOP. It's right here. But yeah, anyway, just so that you know where to find them. So if you can't find a headline code functions, it should be methods. And variables are also referred to as properties. And in fact, properties have something more to them, which we will also look into, because variables can be broken down to two functions actually. And at that point, we call them properties. And so what can you do with data, right? You can get them or set them, like in the average scenario, right? And then they may have functions and so on. Because variables, essentially, the data you store, every data has a class. So if you store these xy coordinates, this is a vector. And Godot actually has a class called vector too. But you can just store this as a variable and refer to this instance, which is the player's position in our little example. So when it comes to properties, you can actually assign a so-called getter and a setter function, which we will see in practice, but this is useful because if you were to set the, for example, the player's position, you may want to notify an enemy, right? Or something. I'm just trying to come up with an example, really. And, well, you don't really need to overwrite what the getter is in the average scenario, but it may be useful for logging. So I think we can look at the code. Okay. So what do we see here? Oh yeah, you can just ignore this for now. This will be useful a bit later. Okay. So this is a script I created on this label node. Labels in Godot are to display text. So if I type hello, you can see it stays on the screen, and if I launch the scene, it will be here. This is actually a UI element, the label, but Godot has ways to like embed UI nodes under in-game world nodes, but we'll get into that too. Okay, so what you need to know for now is that I created the script and I created this as the child of the label. I'm actually going to create a new script. You can do this by pressing right click, create new, and script. I'm gonna name this something different. Let's call it my label. Oops. You can actually set what it inherits from here. And create. Okay, now we have this empty script. I'm gonna assign this to our label. And now it has this script, right? So, as you could see, we told the code told the script to inherit from label, and it actually shows here. it says extends label. So extends is the keyword we use for inheritance. And something really useful you can do is if you hold Control and click left click on a class or actually even functions, you will see it will take you to the built-in documentation, or if it's your own script that you are trying to open, it will just open the proper classes script for you. So yeah, Godot has this built-in documentation. It's pretty cool. And when you're in doubt, you can just Control left click and you will see the entire documentation of the ready function as well. So, okay. As you can see, we have two functions here. So let's look at ready first. By the way, this is a comment. You can write comments in the code using hashtag, and it will just not be considered actual code that has to be executed and revised by the compiler. So yeah, you can just write documentation there and explain what your code does. Okay, so here's this pass keyword that may be strange. Pass is if you like so if you have an empty function, right, just like this is going to throw an error expected in the indented block after function declaration. So basically it's looking for a function body for ready because in the instance of this, ready, this is the function header and whatever you write into it is supposed to be the function body. And if you write pass, you can just keep this function empty. Basically, it tells Godot to know that this is empty and this is fine this way. All right, and we covered what these functions do, and you can watch the video from yesterday or last week. It was not yesterday, that's for sure. You can watch it right here. Okay. And you can see for process, we have this thing here called delta. So this is a argument of the function because functions may work with input data. You can interpret it like that. Parameters or arguments are inputs that have the function. So let's say we had a move function, right? And then the potential parameter could be a vector to describe how much you want to move by, for example. And we can also create arguments that don't necessarily have to be assigned, so they are like optional. For example, if I set function move, we will tell the let's call it offset, right? Which describes how much we want to move by, and we could say what should this be? Alarm enemy, for example. And then we just write pass because this is going to be empty for now. And if I say that this is a variable that can be either true or false, but in the average scenario it will be true, then we will just say equals true. And this way, we don't have to always assign this. We only need to do it if we want something different from this. So if I wanted to call the function, I just type its name, the parameters. I'm going to type vector 2 20 0, We will talk about what this kind of thing is in a minute. And you can see this works just like this, but if I remove this, it is going to throw an error, too few arguments, because it accepts us to assign 2 arguments. If I just type the second one to be false, it will be good. If I gave this true, that's also good, but what if I typed this? Well, that's not true or false, is it? So, what's the solution to kind of like sort these instances? That's where types and classes come in. Because here's this thing called dynamic typing and static typing. I'm going to get back here. Static typing and dynamic typing. So you could guess the typing indicates the way we write the code, and that is correct. The most important difference is that you don't need to tell the class or the type names here. And here you have to like, it's not that you have to, but you do. Types indicated. So therefore, this is more error prone, right? Because I can just do this, and if I want to like see if I should alarm the enemy, right? I could not, because here's all this crap that we cannot interpret as a true or false variable, because this is just text. Okay. So how do we assign the type, and what types are there? I'm going to come back here a bit and show you the primitive data types that actually build up pretty much everything. So first, we have numbers, right? We have integers, which go by the name of int, and floats, which allow decimal digits. I don't know if Godot has... Yeah, it doesn't have double, okay. Okay, because in other languages there's double, which has double the precision as float. Okay. So float can be like 3.1236968, whatever. However, an integer can only be 3, like compared to what a float can be. However, a float has limited precision, because you know, there's only so much space in memory in RAM, which we talked about the last lesson. So you know, you can just display a million digits with pretty accurate precision. We have booleans, and this is true or false. This is these 2 possible values, and oh, where am I? Okay. You can even see if you click on a label, see the script text variable in the inspector of this node. This is a boolean, true or false, right? You also have text data, and this can either be a single character or a string. And a string is, as the name suggests, a array of characters, basically. This is not really the primitive data type, by the way. String is not really primitive anymore. And so now that we've gone through these three basic things, it's also important to mention that all of these can be displayed using numbers regardless, because booleans, they are either 0, 0 or 1. We also saw binary code the last lesson, and that's basically the same thing as booleans. And then text data and the characters can also be described by numbers, because here's this thing called ASCII code, and then all the encodings, or the code standards. You may have heard of UTF, Unicode, stuff like that. These all define the numeric identifiers of every single character. I think that's it for the primitives. Yeah. And so you also have arrays and classes, right? Because classes can incorporate every primitive data type, and these are basically what build everything up in a way. Even arrays, because so array is a list of data. That's what it is. You can create an array of like numbers, so it would be 1, 2, 3, right? You can store anything you want, right? You can just store any resources, any nodes as a reference. I think we mentioned value and reference-based variables the last time, and it is pretty important with arrays, because arrays are reference-based too. Even though they store value-based information, arrays as a whole are reference-based. They point at the array, at the list of information they describe. Okay. Oh yes, so now that we know the data types, we could somehow make this work, right? So the way you statically type a arguments class is by colon and the class name. So boolean is called bool, and see now, as I typed it, it just threw this error. Cannot pass a value of type string as bool, because this is a string, right? A series of characters. And you may think that, oh, but hey, there are arrays, right? They also are a list of data. Well, yes, but strings are so common that many languages just have it offered as a built-in functionality to, like, contain this chain of characters without, because if you wanted to type this text, hello, I'm Adam. If you created an array, use the var keyword, and then you type the variable's name, you can refer to it by, we could call it introduction text, right? And if this was an array, we will need to store every character as its own value. While we could just assign this right away. Okay. So strings need to be contained between these two symbols, right? The quotation marks. You can use the single quotation mark inside a string, but I think if you refer to it like this, yeah, because you can contain strings between either single or double quotation marks, but I just prefer double because in the average text, this one is more common for shortening stuff, like I'm instead of I am. But yeah, there's that. And you may be wondering, what if you wanted to say a quote in a text, right? Well, the thing is that we can actually use quotation marks because here's this thing we call escape character, which is the backslash. You can create it by right alt and Q, at least on the EU keyboard in the Hungarian character set. But so anyway, with the escape character, you can actually type this quotation mark without it being detected as a string closer. Because this basically tells Godot that the next character has to be ignored if it would be something specific. And there are also special characters you can put after the backslash to indicate functionality. Because if I wanted to say, hello, I'm Adam, right? If you wanted to display this, you can just hit space because, sorry, you can just hit return or enter because Godot is still going to detect this as if it was just this text this way. So we have \n to deal with this for us. And let's solve this real quick. Let's solve this thingy that's constantly showing up. So yeah, we can assign this a Boolean value now. And we can do the same thing with the offset. We can tell this is a vector2. And if you are declaring a variable that's not a primitive, or it's like a built-in Godot class, then you can do so by so if I hit enter on vector2, this is not going to work. It says built-in type cannot be used as a name on its own. So basically we need to create an instance of vector2, and you can see it shows these 3 lines. These froms are not really important. It's just basically copy another vector. But you can see we have this one, which says vector2 x is float and y is float as well. So if I type this, then there we go. Because vector2 has this function to create an instance with this predefined data. And you can see vector2 is typed here twice. Are they dumb for like displaying the type twice? Oh, what's this? Well, this is the return type of a function. If you come here, right, control left click, you will see this header code constructors. And here's the thing we just used. Constructs a new vector2 from a given x and given y. So a constructor is the thing that initiates a class instance. And a constructor's return type is always its own class. You can see if we scroll down here, the methods or functions, if we were to use a vector's angle function, it will return a float, which is, the number capable of displaying decimal digits and other fractionals. We can indicate a return type or tell Godot that we are going to return a particular type by doing arrow and the type name. Right. So if I wanted to return that we are going, if I wanted to return how much we are moving by on the horizontal axis, I would say return. Here's this return keyword, and then offset, and then what? So we know that vector2 has x and y as its properties, right? We can also see it here x and y. So we refer to a class instance's variables and also functions by typing dot. And now you see this pretty long list, and you might think, hey, this is similar to what we've just seen in the documentation, because that's right. And if I press the up arrow from the first function it suggests, we get to the end, and here's x and y, indicated with .p for properties. And there we go. Now return the x offset, basically, of this motion. Okay. So if I wanted to display something on the screen, or not on the screen, in console. Console is this little window here. You can also see these logs for errors, and whenever I set something, you can see it just prints it. So if I want to display my introduction text, what can I do? First of all, we have this function called print. This is in the global scope. You can see this. This is actually pretty special of a thing, because global scope is not entirely a class that you can access in particular. It's just like every existing class and instance in Godot accesses anything that's in the global scope. And this has so many functions and variables, you can just see how long this list is. So here we have all the methods and all the properties for several things that we will also look at. But yeah, okay, so print is to display something in the console. It can be anything, but now we want text. So this variable is called introduction text, right? So do I just paste it in and it works? Apparently not. Identifier introduction text not declared in the current scope. The current scope. It's not declared. So here's this thing we call scope, and it is also pretty important to understand because we have these levels of depth, and if you define something inside a function, you won't be able to access it anywhere else. However, we can define a variable here outside the functions and inside this class. If I put this out here, now the function will see it. So let's see if it prints it. It does not. Why? Because we have to call the function. And as you can see, here it is as we expected it. It has the new line and the quotation marks. I can just remove this and you'll see now it's in a single line. There we go. And yeah, so this scope is pretty important, and also when accessing other classes, I'm going to create another script real quick. My other label, which will also inherit from label. So if I create a variable called something and make it b6, we actually just seen this right here, but we can access these variables if they are in the class scope and not in the function scope, because as soon as the function is over, those variables that are declared in the function will be gone. So if I do this, A will be gone as soon as the last chunk of execution is done. So after this print, right after this function ends, A will be removed. However, if I do this, if I have B defined here, and I just set its value here, B will still exist because the variable is actually in the class scope. The only thing we do here is set its value, and it will maintain its value too. It won't be gone. So you could see that we can create a vector instance like this, but it can also be done by saying var move offset. Let's call it move offset. It can be done like this, I think. Oh, it cannot. Okay. So it doesn't work in built-in types. All right. We will just use this. So if I want an instance of this other label class, we can access it using two ways. One is copying its path I think this should be it. Yeah. So we can just get its path, and here's this function load. This is also in the global scope. This is actually part of the GD script class. And it has a bunch of other things. Also annotations that we will look into later on. And so load basically just, as you could imagine, loads the script. And we have this new function You can tell it's a function because it uses these parentheses, and if it's just plain text, then it's a property or a variable. So this new function creates an instance of a class or a script, But to make this easier, we have this keyword called class name, which allows us to refer to a script using the class name we assigned. So now I can write my other label.new, and I think that looks a lot better than just doing that load and the script path is just too messy. Okay, so now we have this other label, and we have the variable called something in it. You see, we have it popping up here. And its type is known because, we just told it. So Godot will just offer the unique properties and functions first in this list. So let's do a little experiment. I will print other label.something and then set it to be something else like this number and print it again. Let's see if this works. And it does. So this is how you assign something or a variable to or data to another variable. Okay. We basically gone through this. We have return. Yeah, we have this covered. We have this. Okay. All right. So we've also covered abstraction in a way with inheritance, right? Because when you structure a game, you have to think as abstractly as possible to create the cleanest code, and that may take some trial and error, but yeah, it just takes a lot of experience and figuring things out, As for reference-based variables, I wanted to show you guys this piece of code. Oh, wait. So first of all, oh yeah, you may see something new because here we have colon equals and not just equals, because colon can be shortened for declaring the type of something. Like this is basically the same thing. These two are the same because Godot can infer the type of this assignment. And we can also do this here because this clearly indicates that this variable clearly indicates it's of the type of my other label, because it's just in the name and we just create a new instance. Okay, so here we have this. I'm going to do this one as well. Okay, we have A, which is an array that has two elements of 1 and 2 respectively. And we have B, which for now equals only A. Arrays have a function called clear, which just erases its elements. So the array becomes empty, right? So after it's clear, B becomes empty, also indicated as these square brackets. And if I print A and B, what will happen? You can think about it yourself. This is just related to reference-based variables. So let's run it. Both are empty. Why? Because arrays are reference-based. So if you look at the memory, right, our RAM with 4 data slots, we have 1 and 2, and A and B. So A, since it's reference-based and it's a pointer, it points at the beginning of the array, which is 1. And when we do B equals A, then B is basically going to point at A. But to get the value that we're looking for, B needs to... So B points at A, and then B needs to see what A points at, right? To use its set of values. And so they basically represent the same thing. So we have this pretty cool function called duplicate, which basically makes a copy of the variable. You can see this is inside the array class. And now, basically, you can see if you press Ctrl space in here, you can see the function designation. Deep is for like nested resources and all this stuff. We don't need to worry about that. But the return type is array. So this is basically the equivalent of typing this, except we have it as a variable, right? So now if I run the code, you can see A is still intact, only B is empty now. Okay. We haven't used process yet, but let's just do a print in process as well and print this data. You can see data is the elapsed time since the previous frame. So basically with this we can determine FPS. You can see it's printing every frame. See how this number keeps increasing. This means we are at 30 FPS. We can do 1 divided by delta. Yeah. Because we can do all these cool operations with numbers. And this is what we are going to look at first. So let's just get back here. We have this alarm enemy boolean, which is a true or false variable. Even this has a class description, and this explains it pretty well. So we typically use booleans for conditions. So we have this keyword called if, and you just say whatever logic you want to include here. So if I say if alarm enemy colon, whatever we write here is supposed to execute when the enemy has to be alarmed. Now, what if we want to do something when this is false? We just type here. Let's see. Oh, yeah, sorry. I'm just gonna remove that. So now both of these fired, which is not good, right? What if I set this to false? Now only enemy not alarmed is shown, which is this. But so, if this is true, both go off, which is not good. So we have this else keyword, which makes it so that it executes if the condition above is not met. So now it's enemy alarmed. If I set it to false, it's going to be enemy not alarmed. Now, what if we want to see how much we will move by? Let's say we do if offset.x, and we can use relation signs, also keywords, but yeah, we can't express this with words. So if offset.x is bigger than 10, we print more than 10. And if it's less, then we just say less than 10. Okay. What if I wanna know if it's more than 15, but I don't want this to print? But what if I want to say if it's this is going to be good. So I could just do this, right? If offset x is bigger than 15, we will print more than 15. However, this still fires. So you might think we could do an else here. And that works. However, if this is a longer list of conditions, there's gonna be a lot of else's. So here's this keyword called elif, but that's how you type it. It actually stands for else if, which is else but with a additional condition. So now if I run it, it's going to say more than 15, because this is 20. If I tell 12, now it's more than 10, and this does not print. We also have logical operators. So how do we define if the offset is between 10 and 15? Right? So it is going to be more than 10 and less than 15. We could just do it in an if, right? More than 10. And this is literally a keyword. Or you could use these ampersands. You can look up the logical operators. They are the same in pretty much every programming language, but Godot has these as keywords as well. So now the between prints. We also have or. So or executes if one of the conditions are true, or if both of them are true. We also have this not keyword, which is a negation logic. So if I were to type this, when do you think this would be called? If offset x is bigger than 10 and not offset x is bigger than 20. Let's try it with 12. I'm just going to remove these. So we are inside. What if I make this 21? Now it does not print because this condition becomes true, right? Because it's bigger than 20, but we need it to be less because we are negating this condition here. And then we also have this, Godot doesn't have it, okay. I think, yeah, okay. There's just this thing called the exclusive OR, which only works when one of the conditions becomes true, and like all of them cannot be true. Otherwise, the branch is not executed. Okay, so these are the conditionals we have. You can look these up in detail because they are pretty fundamental. And we have some other thing called loops. What if you wanted to just print every number from 1 to 100, right? Do you just do this and like modify every number? Of course not. So we have loops, and the way you use them is the keyword is for, and then you need to name a variable here. Usually we call it I for index. And then if you want it to go in a range, you say in range 100. Now we can use this variable. This variable is going to change every cycle. So this is going to run 100 times. Let's see what happens. Okay, we have all these numbers here, but something is wrong. It starts from 0. Because typically we count and index everything from 0 as well. So let me show you. You can also print the elements of an array and access them, and you do that by typing a square bracket and the index of an element. So let's say I want to print the first variable here in the first index, right? It prints 2 because arrays are indexed from 0 as well. If I say I want to print a0 for the 0th indexed element, it is going to be 1 now. So basically here you can specify the beginning of a range as well as the first argument of this range. You can actually see it here. It is described quite well. Starts from B, increases by steps of 1, stops before n. So yeah, if I run this now, 100 will still not be printed because it stops at 100, right? You can imagine it's so that I becomes 1 on the first cycle, and it becomes 2, 3, 4 until it becomes 99. And to reach the end value 100, it will just quit and not run the next cycle. So we can do this, right? And now it is all good. You could also do just simply this and increase the value of I by 1 here when you print it. not like this, because this would actually like increase the variable's value. I phrased it a bit incorrectly here. But yeah, you just change what you print and not the actual variable. We can run this and see how it plays out. And you can see it still prints correctly, right? However, some numbers are missing because, so let's just run this through in our head, right? Here, I is 0. Then we tell I to be I plus 1, which is 1. And then we print I plus 1, which is 2. However, at the end of the cycle, I gets reset to whatever count the for loop was keeping. And so I was 0, right? At the beginning of the loop, and now it becomes 1, and then 2 and 3 and 4 and so on. Okay, we can also specify the step count, or like how much we want to increase the variable by, or how much we want to decrease it. And that's the third argument, as seen here. So you can see now we print from 100 to 1. We can also specify other ranges. So if I want to print every variable of A, I would type A dot, and array has this function called size, which returns the size of the array, which is, 2. So if I want to print every element of an array, I would type AI. And see, this works. In case you think I'm messing with you, and that these are just like indices, see, 5 and 9. There we go. We can also do this for element in A. So this basically takes every element of an array, or every value stored, and names it element. And you can refer to it like that in the scope of the function, or the loop. That's pretty important, because if I wanted to print element here, it wouldn't work because it's just not declared. We also have a while loop, which runs until the condition you give it is true. But we need to declare a variable here ourselves. So we could do by I is less than 10. And we also need to increase its value manually. And we can do this cool thing, this plus equals symbol combination, instead of just having to do this, it's just a shorthand. So yeah, now numbers are printed from 0 to 9. These are the two loops we have. You can look them up if you wish to. Okay, we got this, these, and this. Okay. One other important keyword is const, which stands for constant. And basically this is a variable data that you cannot change. I call this my data. And if I try to modify it, cannot assign new value to a constant, right? This is useful if you want to know what specific numbers are for. So if I wanted to create default HP, right, and I want it to be 100, and when the player spawns I want to assign this, it's better than just typing 100, because you can just, keep track of what this value is for. And it also cannot be changed. So this is basically for code cleanliness. And the compiler is basically going to just take this value and replace this with the actual value before starting to compile the code. So yeah, this is just a pretty nice thing we have. And okay. One last thing is what we call autoloads, and there's the singleton pattern. So think of a situation where you want to have a lobby, for example, and you want the lobby to be managed, right? So you would create a script called lobby manager or something. And you don't want to have multiple of those, because why would you, right? It's a class to like manage gameplay logic, connect the players, all that stuff. So for these, we have singletons or autoloads. I'm going to create this script. And to make it a autoload, you just select the script here. You can modify how you will want to refer to it. And there we go. You cannot assign this a class name because its class is already accessible from anywhere else. So if I just type lobby manager, you will see it appears with a different icon than like my other label, because you can just access it as you wish. And if I wanted to create a players array, right? Make sure to save the code because some changes may not go through off the bat, and that will just lead to errors. So I can access the players here. I don't need to create a instance of the lobby manager. And if I run this, so we have the scene tree here. This is local, which is like whatever we are looking at right here in the inspector. And this remote is the runtime state of the game. And you see lobby managers here. So autoloads get spawned at the beginning of the project when you're booting it up. You also cannot instantiate this. You cannot create a new instance. Or, well, you can, but it's just, it makes no sense. Oh yeah. Oh yeah, so you actually cannot, but it did not throw it up. But so, because it's a singleton and is used for the purpose of being single, right? A single instance object. You cannot create more instances of it. And so this player's value, you can access it from anywhere you want to. I typically make a class called game manager, which is responsible for settings and all those things. So yeah, singletons are quite useful. And to close the session, I want to talk about the debug tools we have so far in Godot. It's actually quite good. So as I'm dragging my mouse, you can see this red dot following here. If I click, it stays there. So what's that? This is saying breakpoint. So now the code just stopped, basically. It stopped execution because I told it to with this breakpoint thingy. And this is useful because we can monitor other variables. you can see all the so-called locals here. Locals are the variables that are within this function scope. And even though the A, B, and I are declared later, the compiler already knows they are there. They are just null. However, if I move forward with this, you will see now the arrays have their corresponding values. Right, B is empty as it should be. And we have I here. We can actually step once again, and this loop is going to go on. Now I is 1, I is 2, 3, 4, 5, 6, 7, 8, 9, and it finished. One other useful thing is the stack trace. Here, this little window specifically, where the stack frames are stored. I thought this was called stack trace, by the way, but anyways, so this tells you where the function was called, or where the line was called from that you put the breakpoint in. This is going to be really useful for debugging, because oftentimes something will just go wrong in a previous function, and you will be able to directly monitor this and jump back to wherever your thing was called from. So yeah, there's that. This is a lot to digest. So I recommend everyone just checks out all these documentations as well, and you can just look around online, mess around, and if any errors show up, that is completely okay. You can type it into Google or ask us or something, because you will get errors and you may have a faulty code, but the important thing is to learn how to handle the issue and not how to just get around it, because if the issue happens once again, you will have a hard time figuring it out if you actually don't understand what the error says. And that is the important thing in programming, like understanding the errors and the things the computer tells you. So yeah, how's that? This was the second lesson, and I'll see you all next week. Okay.